and welcome to the NADA Tech Channel. My name is Steve from NADA Safety Test Solutions Germany. I will be accompanied today by Sabine Dürr and Jürgen Gehrig, also from NADA Germany. So today's topic is the new user interface of the upcoming SignalShark Firmware 2.0. You can write your questions into the chat. We will collect them and answer them in the FAQ session at the end. So during the presentation your microphone is muted, and in this FAQ session we will open your microphones at the end so that you can also ask your questions directly into this meeting here. So let's start. So with the new SignalShark, so in the past we have the spectrum monitoring functionality, direction finding, interference finding, and of course also you can use it as a spectrum analyzer to, especially with the IQ analyzer for example, to deeply go into the signals, find out what it is, things like this. And now with the new firmware we also have EMF measurement capabilities, meaning you have really now one device that can fit many applications and you can do a lot of things with it. But maybe you'll be a little bit afraid additional new functionality into this device, maybe it's getting even more complicated, but this was really the goal of the development, to make it even easier than before. So in the new user interface you will see it's a little bit more modern, has a modern touch, a little bit more colorful, rounded edges, things like this. But the most important difference is now the new Add Task menu. So let's look at it directly onto the device. So if you click here on this plus icon in the tab bar, you can, in the first section here, you can change existing tabs, existing tasks here, duplicate it, rename it, whatever. And then if you want to make a measurement, you just press on this Add Task menu, and now you have here this little nice tiles. And the idea behind is like in a shopping app where you have a picture of your product, you have a title, a little description, things like this, and you can just add it to your shopping cart. Everyone, or nearly everyone, is now used of this behavior, used of shopping apps. So this is something that everybody can operate, and this is the idea behind. So you do not start with thinking about parameters to set up, thinking about which task or view you need. You just start with like a shopping app. You just look here which of these setups is closest to my application that I want to do, and then you just simply select it. And each shopping cart, let's call it shopping cart, has this little thumbnail that shows the application what it is. It has a title and has a little description. If you press on show more, you will get some more information about it. In the final version you will also have this on-screen help with even more information, with a little application note behind it. If you have this little NADA icon in the top right, this means it's a setup made by NADA and is right protected. But of course, as a customer, you can also make your own setups. In the second firmware release, it will be also possible to set up a thumbnail like this. In the first release, you can give it a title and give it a description. So then maybe you have here several tiles, and it's maybe first hand a little bit difficult to find the things you need. For this we have added this filter section. You just click on filter, and then for example we can say we only want to have setups for EMF measurements. We click OK, and then only EMF measurements are displayed. So let's start with a simple one. Let's take here this EMF measurement percentage of standard. Click to add. Then you will be asked to add it to the existing tabs or to replace all others. So let's replace. And then everything is loaded, everything is prepared, and normally the customer then just have to change small properties like the start-stop frequency or yeah, maybe things like this. So everything I explained today will be also covered in a presentation that we will put on the extranet, so that you have or you can just look into it and get answers to your questions. So the next step was a cleaner settings menu. So in the past you have really a lot, if you press on settings, you will have really a lot of tabs there where you can change things, and it was a little bit difficult, cumbersome to find the right tab. So we decided now, if you press on the settings tab here, you have now these groups. So in the first group, settings, you have the general settings like date, time, color scheme, things like this. The task synchronization tab. Here, for example, you can select which parameters should be synchronized between measurement tabs and which should not. So let's take here, for example, the input. If I switch this here off, meaning the antenna input will be not synchronized, and let's just add another tab. So now we have two measurement tasks here, and let's change the antenna input, let's say for this one here, to antenna input 2. So there's no antenna connected, antenna input 2, so we do not see anything. But if you go back to this tab here, we see, okay, there is still antenna input 1. And if we now switch on synchronization and we select here our antenna input 1, at the first tab, and we go to the next tab, radar, we now see also the next tab has this antenna input 1. So task synchronization means here you can switch on and off synchronization of parameters between tasks, and here we have our regular network settings. So if we go to the next group, this is file handling. Here you have the data logger, where you can just select a folder or set up a structure. You can select a folder for storing data and storing screenshots, for example. And there's also a tab for setups. If you want to make your own setups, you can make this here in this structure. And here you have the save settings. So for example, you can select, if you press the save button, if you want to save just a specific, the active task, or if you want to save all measurement tasks, if you want to have a user input when pressing save for the file name, or if you want to have a default file name, things like this. So this is the second group, file handling. The third group is editors. So here we have the transmitter table. Transmitter table is the same as the service table in the SRM. We have the antenna and cable, so that you can put antenna and your own antenna and tables, or can use your own antennas and cables. And then, for example, you can just create one and enter all the calibration points, and then even with your own antennas you can measure in, for example, volts per meter. And something that is also new now for the new firmware 2.0 is that an EMF standard editor is directly integrated into the firmware. So here, for example, we have an IGNIRP standard. You can see here the diagram of it. You can go to edit and see all the values for the E field and the H field. So if it is another or a standard that is that was created by NADA, then it has this file ending NSTD, and you cannot change it. It is write protected. If you make your own standard, then it has this ending XML. So it's also possible to make your own standard. So let's select here this ignib, set it active, and then we go back to the main menu. So something that is now also new. So we have this EMF standard editor, and of course we can now also measure directly in percentage of standard. So we have selected this new standard ignib 2020. Let's go here to the EMF spectrum. We select it here as the display unit. We select percentage. And for the max, we can go, for example, with 110%. So now we have at the top our 100% line, and we see now here our traces relatively to our standard, to 100% of the standard. So this is also quite nice now. So I also showed you another improvement. We have now a third line in the user interface. So if we look at the bottom here, in the past we just have this reference level input, things like that. Now we got a third line with the information for the selected standard, for the transmitter table or service table, for the connected antenna cable, and also for all the averaging information. So the idea behind this, that if you now make a screenshot, you have the information in the top left about date, time, about your position, where you have made this measurement, and you have all the other information in this parameter bar here at the bottom. Additionally, we have a new button on the right. It's a button for selecting the axis. So now that SignalShark can also make EMF measurements, it's important that when you connect an SRM antenna, a 3-axis antenna, that you can select an axis. So if we open this menu here, you can select between directly X, Y, Z axis if you want to measure it manually. But you can also select this automatic isotropic measurement like here. And if you do the selection, it's also displayed directly here in the plot, like in the spectrum plot and the spectrogram plot. So let's assume we have connected an isotopic, automatic isotopic antenna from NADA, and we want to measure some radar signal. So for this, we have a dedicated setup like this here. Then we can go to the access menu. We can switch from automatic isotropic to manual isotropic. And then we can say signal run. And let's say here we have an airport surveillance radar, or the frequency range of an airport surveillance radar. And this radar has a rotation time of 5 point something seconds. So let's say we want to really be sure that for each axis we cover at least one rotation. Then we set our time here to, let's say, 6 seconds. We go to our manual isotropic measurement. We select the mode single and we press start. And now it automatically measures 6 seconds. Grab the signal. I think we have to align this here a little bit. Measure the y-axis. Here we cover the signal. Measure the z-axis. Here we cover the signal. And show the result. And of course, We can then also switch to a different display unit. So let's go, for example, so I think it was the, yeah. You can also switch to volt per meter then in this example. So here everything is also explained in the PowerPoint, so that you can also then have a look in detail if you try the firmware out by yourself. And also this presentation will be recorded so that you also can watch the video at the end. So something very important is now that we have a new trace menu. If you look back to the former firmware 1.9.8, the trace menu looks like on the left side here. You have up to 8 traces and you can switch them on and off. So Holger Schwarz has made a really nice application note about how the traces work with the detectors and post detectors with plus peak error mess and so on. And in the old version you just have the ability to switch them on and off. And if you want to have something like max hold, you can use this infinity max min button. And in the new firmware we have made this a little bit more user friendly, and we aligned also to all traditional spectrum analyzers. So with a regular spectrum analyzer or oscilloscope, normally you have your trace menu, and then you can select by yourself which detector you want to have, which post processing you want to have, which name it should have. So this we have now also implemented with the SignalShark. So if we now click here on our traces menu, you see here now also 8 traces, but just the traces that you really need are in use and all other traces are grayed out. If we go now on the trace, let's take this here for example, then you can give it a name. So I think it was around about 5 characters. You can give it a color, and you can select the trace type. So in the moment we have none, meaning trace is deleted. None means it's just a grayed out trace. And we have this normal trace. And in future we also will have a reference trace, so that you can, for example, have a trace. If you have already made a measurement a day before, you can store it, and you can use this stored measurement as a reference trace. Or you can use standard as a reference trace. If you not measure in percentage of standard but in volt per meter, then you can, for example, display the trace line of the standard in comparison to your regular trace. And we will also have mathematical traces. So in the first release we have this normal trace, and then you can adapt it. You can adapt the detector and you can adapt the mode. So if you select the detector, we have this plus, RMS and minus peak. So what does this mean? So if you look in at the spectrum, we have several bins. So a normal so-called FFT takes the data, calculates values, so it makes, let's say, little channels for each frequency range, and the RBW gives you the resolution, so how many little channels you will have. And in the SignalShark we have an FPGA that makes all this processing, and it records thousands or hundreds of FFTs in the background. But this is too many data. It cannot be displayed all at the time in the display. And even if you would display it, the human eye is not able to analyze it because it's just much too fast. And for this, the detectors comes into play. So let's assume we just go with one spectrum bin, so this red one spectrum bin, and look at this over time. So therefore we have the detector. So now we have this one single spectrum bin. Over time, the gray line should just be the value over time. And the plus peak detector will now take, you set up the measurement time, and let's say the measurement time is 10 milliseconds, then the detector will wait 10 milliseconds, will record this bin over time, and then it will, with the plus peak detector, for example, it will just take the highest value of this 10 milliseconds for this bin and display it. For the minus peak, it will take the lowest value, and for the RMS, it will take the root mean square value. So this provides the true power measurement and is the closest to what the signal really is then. And so that's why the RMS value is mostly used for EMF measurements. So let's go back to the device to see it. So now you can select the detector. Just remember, we have this plus peak, so it will take, for example, 10 milliseconds and will take the highest value of this 10 milliseconds and display it in the spectrum as a bin, the RMS or the minus peak. But what happens if you want to have a longer time? So for this trace mode, you can have the clear write. Clear write means if new data is available, the old trace is deleted and the new trace is drawn. The average means you can measure, for example, for 6 minutes, and then the RMS value is even averaged again over 6 minutes. Max hold means it will always just take the highest value and will stick to it. And max afterglow means, for example, if you have the 6 minutes, it will take the highest value for 6 minutes, and if the signal then disappears, it will slowly go down. So sounds a little bit complicated, but that was already implemented in the old firmware version. The only thing it was not so easy to configure. So let's say you want to just switch on and off a trace like in the old version. For this we have the presets. So let's say we just want to have a RMS trace, then we select RMS, and it automatically will set the name, the function, and everything else. And as a second trace, we want to have RMS averaged. So this was in the old firmware AVR trace. So it's like this. So it automatically will select the detector RMS and the mode average and give it a color. So, and then we are ready to go. And the good thing, remember, with the new firmware, normally the customer don't have to care about this. Everything is preset, and the customer just loads this the setup, this little product tile, and everything is already done, and just the customer just then have to select, for example, frequency range or things like that. So another difference is now the measurement time, because in the past the measurement time was directly located here in the main menu, but the measurement time is normally related really to this, as explained before, to the traces, because measurement time says for this detector how long should the detector take values in the background and apply the detector, for example RMS, and display it in the trace. So that's why the measurement time is now located here in the trace menu. If we click on it, we have now additionally modes, making it even easier. So if we go for interference finding, for example, we can switch to as fast as possible. And this mode is good. It doesn't matter what you set for this frequency span or for the LBW. The measurement time will be automatically chosen that it displays as fast as possible the traces, and this is very good for short pulses, things like this, to cover it. If we are in the RMF, in the EMF range, we can select the EMF mode, and here the FPGA will care about the number of FFTs that are used for each detector. So this has something to do with statistical values. So in the EMF mode, the FPGA will collect at least 100 FFTs in the background and then calculate, for example, the plus peak or RMS value and display it. And therefore, you can really be sure that this RMS value is statistically absolutely correct. And of course, you also have the possibility to set the measurement time manually. And something that is also adapted now, let's say you have made a spectrum measurement with another device, and there you have a scan time of 100 milliseconds, and you just want to make a comparison measurement with the SignalShark. So this is now also easy going. You can just go here, say 100 milliseconds should be the scan time, and then the analyzer will automatically be set up so that the scan time is 100 milliseconds. So what is the difference here between measurement time and scan time? So SignalShark is a real-time analyzer with 40 MHz real-time bandwidth, but if you go above this 40 MHz, it has to stick together several 40 MHz measurements to get a whole span. So here for this example we have a frequency range of 1.7 gigahertz up to 1.9 gigahertz, and now the SignalShark sticks together several 40 megahertz measurements to cover it. So meaning measurement time for 40 megahertz for one step is this example here, this 4 milliseconds, and to cover the whole range from 1.7 to 1.9 gigahertz you need this 100 milliseconds. So you can select the scan time manually, or let's assume we are in the EMF measurement domain, then we go for EMF, and it will be automatically set up that it makes the measurement as fast as possible, but has at least 100 FFTs for detector value. So also this thing is explained in the presentation here. So when you know also about the SRM, you know it has two different average modes, possibilities to average values. So if you go now here in the trace menu, there's also the possibility to average about a number of measurements. So in this example here, more than 40,000 measurements will be averaged to one trace value. Or you can select the time. This is more common in the EMF domain. So let's assume we want to measure or have a 6 minutes average value. Then we just enter our 6 minutes. Okay. And now it will make an average measurement here with this purple trace over 6 minutes. And you can also see here the progress bar like in the SRM. So to see it a little bit better, we will reduce the average time to, let's say, 30 seconds. So now you can also see here the progress bar going up. And if it is then at 100%, you can say, okay, my measurement trace here is averaged about the average time that I have set up. And at the end we have even a new view called channel meter view. So this is a really special thing that we go in now. So go live again. So let's add a task, and we go here for this EMF channel power measurement. Let's replace all the other. So now this is our only measurement, and what you can see here is now a spectrum view giving you an overview about what happens in the spectrum, and a table view. So we will just make it a little bit more simple. So if you know about SRM, so SRM has the possibility to integrate over frequency. So there's a measurement integration over frequency where you can select a start range and the stop range in the spectrum, and then it will calculate for you the channel power of this channel. So this is possible with the channel meter here if you just select one channel, for example. So let's do this. Just remove this channel, remove it. So now, yes. So now we just have one channel here, and you see this gray bar. So this represents the channel in the spectrum, and we can now go to edit channel. We can now say our start frequency, our stop frequency, let's say 2.5 gigahertz. You see here it will automatically select this channel, and then will integrate and makes a channel power measurement. The other thing is SRM has also a level meter, and this is true also here. Even in the table directly you get also this level meter view, this bar graph. So let's reduce the channel bandwidth a little bit. Let's say we are just 2.42, for example, gigahertz. So now it moves a little bit more, and here you can see the movement of the measurement like this. And here you can see the bar graph like in the level recorder of the SRM, and there's also an indicator for the maximum value, and all the traces that you have selected here in the spectrum will be displayed here as a channel in the channel meter. And the SRM of course has also the safety evaluation. So let's assume you want to make a measurement at a dedicated place, and you want to measure the FM broadcast value, you want to measure television, you want to measure mobile operators, and you want to do this in one run. So this is also possible with the safety evaluation of the SRM, and this is also possible here now in the SignalShark with this channel meter. So we just reload this measurement again. So now again we have our Wi-Fi channels here. So the reason why we choose Wi-Fi is because it's internationally normally available, it's easy to compare, and if you look here at the channel names, we have channel 1, 6, 11 and 14, and the reason is these channels do not overlap. So you can see it here in the spectrum. These channels are separate from each other, so giving also meaningful values at the end. So what can we do now in comparison to the SRM safety evaluation? You see you have this total and others values, and you have here this channels. So let's maximize it. We can go to first, we can edit groups. So this is something new. That's a feedback from the customer side. They told us it would be great if we have several groups, for example, to cover several broadcast stations, to cover several mobile operators into groups. So let's just add a group. Say group 1. Okay. Add a new group. Group 2. Another good thing or good improvement regarding SRM, as you have seen, you can directly enter it with a keyboard, with a virtual keyboard, or if you connect a regular physical keyboard to the SignalShark, you can even use this. So this makes life also easier if you have to change names directly on the analyzer. So we save now our groups, and now we can go to edit channels, and here we can give the channel a name. We can enter the start-stop frequency, or if it fits better, we can also switch to start-stop or to fsend and or ftune and the channel bandwidth. And of course we can also select a group, so we just click here into the groups table cell, and we select group 1 for example, also group 1, group 2, group 2, okay, save it. And now you see you have even groups here, even with sums for each group. So you have the total sum, you have the others, you have the sum of groups, and directly in this table you even see the level recorder value, which is very helpful if you have several channels to see which channel is the strongest one, for example. And one idea of the SignalShark is, so in the SRM you have your service table and you have your measurement, and you have to care about storing both together and transfer to another analyzer so that it works. So in the SignalShark, everything is stored with your measurement, with your setup, meaning all the views, the setup of the views is stored, but also this channel table is directly stored with your measurement. And if you have existing transmitter tables or service tables, you can directly import this and have it directly here in that value. And if you already have transmitter tables from the IDA or service tables from the SRM, there will be also a script. So if you have installed the script launcher and press on the script icon here, there is a tab. If you go here to the selection, there's a tab converter scripts, and here you can convert IDA transmitter tables to SignalShark transmitter tables. You can convert SRM service tables to transmitter tables, or there's even a template for Excel that you can make your transmitter service table in Excel and import it then directly here into SignalShark. Another converter script here, SignalShark normally stores the spectrum and spectrogram values in the format HDF5. This is a binary format which is very performant and powerful. But if you want to have these values for Excel, for example, you can use the script to convert a spectrum data to CSV file or spectrogram data to CSV file.